an AI project management tool extracted return policy logic from a superseded 8-month-old PDF document. It generated a ticket that was approved in a batch review. The junior engineer implemented the ticket faithfully, resulting in 6 days of incorrect return processing during a peak sale period, plus a mandatory data migration. The tech lead reviewed at the structural level, not the semantic level. The junior engineer treated the approved ticket as a complete infallible specification. This content is AI-generated using deep research and verified sources. We're committed to accuracy over generic AI output.
It's pretty much the ultimate nightmare scenario for any engineering team, isn't it?
Yeah.
You've got this system that is executing exactly as instructed, but the instructions themselves are just entirely divorced from reality.
Yeah, and the structural reasons behind this kind of silence. Why the junior engineer just builds the flawed ticket without ever raising a flag, that's a core mechanism we are analyzing in this deep dive. Because it happens everywhere. In typical sprint workflows, tickets feel like self-contained units of work to the people implementing them. But they aren't. They are actually just these highly compressed summaries of a massive, complex context model that is held almost entirely in the tech lead's head.
Which is incredibly dangerous.
Exactly. When you examine this through the framework of coordination neglect, which is a concept established by Heath and Stardenmayer back in 2000, you see something fascinating. Teams systematically overestimate their shared understanding whenever tasks appear neatly packaged. Because the Jira ticket looks professional and complete, the team just assumes the understanding behind the ticket is equally complete.
And that naturally leads us to the other invisible force at play here, which is psychological safety barriers. If we connect this to Amy Edmondson's foundational 1999 research on the topic, these two frameworks perfectly predict the exact failure we saw in that return policy scenario.
Yeah, think about the power dynamics.
Exactly. Think about an offshore junior engineer reporting to an offshore tech lead. The junior engineer is evaluating code and task requirements for the specific person who controls their performance review. That tech lead dictates their visibility to the broader organization. So asking a clarifying question about a seemingly complete AI-generated ticket isn't just a simple request for information.
It's a risk.
It's a huge risk. It is perceived by the junior engineer as a legibility test, a test of their basic competence that they might fail. The safest, most rational choice is to simply proceed on the most plausible interpretation of the ticket and stay quiet.
I have to push back on that framing a bit, though.
Okay.
If you've ever been in the trenches trying to ship code on a Friday afternoon, you know that silence from a junior engineer isn't always some deep, calculated psychological calculus. Sometimes it is literally just the mechanical reality of pushing through a massive backlog. I mean, theories of coordination neglect sound great in a research paper, but they don't cleanly map to the intense, localized pressure of meeting a rigid sprint deadline. The tech lead is swamped, the junior is swamped, they just build it.
But that intense pressure is exactly what makes the framework hold up. In fact, it holds up under the absolute highest deployment pressures imaginable.
I don't know, it feels a bit academic when you're staring down a Jira board with 40 open issues.
Consider the Knight Capital Group incident in 2012. We are talking about $440 million destroyed in 45 minutes. That financial catastrophe was not caused by incompetent engineers writing bad code. The code functioned perfectly.
Right. The routing logic was technically correct for the old flag.
Exactly. It was caused by a massive structural failure, where the executors deploying the code did not hold the context that the designers assumed they possessed. The system executed flawlessly based on the inputs it was given, but the shared understanding between the team that built it and the team that deployed it was a total illusion. The pressure didn't negate the coordination neglect, it amplified it.
That is a terrifying example, but it perfectly illustrates the stakes here. So, to understand how this shared understanding breaks down locally in your own sprints, we need to examine the specific gaps in communication. The source material we're looking at today outlines 12 critical questions that never get asked between junior engineers and tech leads. We're going to dive deeply into 4 of the most dangerous ones.
Let's do it.
Starting with the cart scope boundary. The unasked question is simply this: which cart state are we responsible for, session, guest, authenticated, or all 3?
It seems like such a fundamental thing to know before writing a single line of code. But engineers default to the largest reasonable interpretation of scope to avoid appearing incompetent when boundaries are unwritten. If a ticket lacks explicit boundaries, the junior engineer just assumes they must handle everything.
Which leads to massive bloat.
Huge bloat. And this is exactly why Amazon's famous two-pizza team doctrine enforces such strict service ownership. They do it precisely to prevent this massive silent scope bleed. And the data backs this up. The 2023 State of Agile report notes that 46% of respondents cite unclear acceptance criteria as the primary trigger for rework.
And here's where it gets really interesting when we apply an AI lens to this scope boundary issue. It reveals a distinct structural limitation in our current tooling. AI coding tools operate strictly at the code and test level. They do not operate at the service ownership level.
Right, they have no idea who owns what.
Take GitHub Copilot, for instance. Copilot has absolutely no access to your organization's service ownership map. It will gladly generate flawless logic for an authenticated cart state that your specific team has no actual jurisdiction over.
It gives you perfectly written code that you have zero business deploying to production.
Exactly.
Which naturally bridges into the next massive blind spot on our lists. Architectural decision context. This is question 7 from the research. The question that never gets asked sounds like this. Why was the decision made to build the discount engine as a synchronous service call, and does that decision still hold given our new Black Friday load targets?
Oh, this one is so common. Junior engineers inherit decisions without the surrounding context that would tell them a decision is conditional or just temporary. The Spotify squad model failure provides incredibly clear evidence of this. You had engineers building major new features on completely deprecated foundations simply because architectural decisions made under intense deadline pressure were never recorded with their temporary conditions attached.
It's like finding a load-bearing wall made of duct tape and assuming it's standard company protocol.
Yes. Martin Fowler's technical debt taxonomy highlights this perfectly. He points out that explicit revisit triggers are what differentiate prudent, deliberate technical debt from inadvertent, reckless debt.
And again, AI tools cannot save you here. They cannot surface those unwritten organizational constraints or the specific painful trade-offs that were consciously accepted at the time the code was written. An AI tool sees a synchronous service call in the code base and just assumes it is the permanent intended architecture. It is completely blind to the fact that the architecture was a temporary compromise meant to be torn out after a Q3 launch. It simply normalizes the technical debt.
It bakes it in. Which brings us to question 9, focusing on measurable degradation thresholds. The unasked question here is, when the requirements say degrade gracefully, what does that mean in measurable terms?
Adjectives are incredibly dangerous in engineering. They are assumed to simply require technical interpretation, which ends up hiding invisible legal or business constraints. Look at why Netflix's chaos engineering discipline emerged in the first place. It happened because the adjective resilient lacked a shared, measurable definition across their distinct engineering teams.
Right. Resilient to one team meant a 2-second timeout, to another it meant a fallback cache.
Exactly. And we saw the exact same mechanism fail massively during the 2018 GDPR rollout. You had engineers implementing technically functional privacy controls that directly violated unwritten legal constraints, simply because those legal requirements were never translated into engineering readable specifications. The code worked perfectly, but it was illegal.
So what happens when we throw AI code reviews into that mix? AI code reviews will miss threshold violations entirely unless they are explicitly configured with access to the business rule documentation. An AI tool evaluating code for graceful degradation will verify that a fallback mechanism exists, but it has absolutely no capacity to know if a 500 millisecond timeout violates a service level agreement that your engineering leadership signed a year ago.
It can't enforce a rule, it can't read.
Let's look at the final question we're pulling from the sources today, question 12, which addresses meeting summary fidelity. The question is, was there a decision made in the verbal sprint planning discussion that is not reflected in the AI meeting summary?
We are seeing this unasked question explode right now due to over-reliance on the perceived objectivity of official AI records. Engineers implicitly trust the machine-generated transcript over their own memory, or worse, they use it as a complete substitute for actually attending the meeting.
I know so many teams doing exactly this.
It's rampant. But Gartner's August 2023 Magic Quadrant for Meeting Technology documented a 15 to 25% miss rate on commitments made in conversational phrasing.
A quarter of commitments just missed. Think about the false alignment that creates. These AI summaries routinely flatten hedge statements into firm affirmatives. Imagine a verbal scope narrowing during a sprint planning meeting where a product manager says they might not need a specific feature for the MVP.
The AI meeting summary compresses that nuance down to scope confirmed.
Yes. The junior engineer reads that summary the next morning, treats it as an unassailable official record from the PM, and proceeds with absolute certainty to build on entirely incorrect information.
Let's actually return to that opening scenario for a detailed walkthrough because it brings all of these structural failures together beautifully.
Okay, walk us through it.
You have an AI project management tool extracting return policy logic from a superseded document. It generates a ticket. That ticket gets approved in a batch review by the tech lead, leading directly to 6 days of incorrect return processing. Now, if I am putting myself in the shoes of that tech lead, I am going to vigorously defend batch approval as a strict time management necessity. Camille Fournier's work outlines that tech leads routinely carry 30 to 40% non-coding obligations. On top of that, Rigby and Bird's 2021 Microsoft research study proves definitively that defect detection drops significantly when a reviewer's load exceeds 300 lines of code per session. Batching structural review isn't laziness. It is an operational necessity just to survive the sprint.
I understand the survival instinct, but that defense fails entirely at the semantic content level. If you look at the 2024 feature sets for tools like Jira AI and Linear AI, they explicitly lack source provenance metadata. The tech lead, who was batch approving those tickets, had zero signal that the content was pulled from an outdated PDF.
None at all.
You cannot batch approve semantic meaning when the AI tool strips away the context of where that meaning originated. A structural review checking if the ticket is formatted correctly, if it has acceptance criteria, if it sounds plausible, that was successful. But the semantic reality, the actual meaning of the words, caused a massive 6-day production failure.
We see a different but highly related dynamic in another scenario, from the sources dealing with that degradation logic we talked about earlier. In this scenario, a junior engineer implemented technically correct graceful degradation, but it violated a numeric threshold that was buried in an unseen email from a partner team. Now, an AI code assistant could have easily helped flag this pull request before it was ever merged.
But only if the team had explicitly configured their retrieval augmented code review tool with access to the business rule repository first.
Exactly. The limitation in that degradation scenario is entirely organizational scope, not technical capability. The capability to catch that error exists in enterprise configurations today. But the crucial decision to connect the AI tool to the business rule documentation corpus before deployment was never made by leadership.
Which brings us to a genuine debate on the deployment of AI in these engineering workflows. Because there are areas where AI undeniably helps, and we cannot ignore the massive efficiency gains.
We shouldn't ignore them. They're real.
AI project management tools show up to 60% reductions in ticket writing time. The value accrues immediately upstream at creation, even if, as we've seen, the risk accrues downstream at implementation. AI meeting summarizers like Otter.ai and Fireflies provide highly reliable artifacts for absent engineers when it comes to concrete, indisputable action items.
And AI code review assistants like SonarCube AI or GitHub AI Review catch an additional 15 to 20% of technical defects. That's based on McKinsey's 2023 data.
Those efficiency gains are real, yes. But the risks introduced into this workflow are equally severe, if not more so, precisely because they are silent. Automation bias actively blocks the critical scrutiny of AI-generated tickets. Approved, AI-formatted tickets simply receive less critical review than human-written ones because they look authoritative. They have the right headers, the right bullet points.
We also discussed the false alignment that occurs when AI summarizers miss conversational commitments, carrying that 15 to 25% miss rate. But finally, you have Copilot version drift, which creates massive compliance risks. The generated SDK integration code reflects the training data distribution of the model, not your team's pinned dependency version.
Which is terrifying for regulated environments.
Exactly. For regulated integrations, this is a severe vulnerability explicitly named in the OWASP AI Security Top 10.
The thesis we have to arrive at after looking at all these structural failures and tooling limits is what the sources call the irreplaceable conversation.
The irreplaceable conversation.
AI cannot replace a junior engineer asking a tech lead why an architectural decision was made. That interaction requires surfacing unwritten tacit knowledge, historical constraints, and human judgment that an AI simply cannot retrieve because it was never externalized into a document in the first place. Evaluating whether past conditions that justified a technical compromise still apply today is a judgment task. It is not a retrieval task.
So what does this all mean for you and your team this week? We are going to close with 3 immediate actions you must take to address this structural failure. Action 1. Add a scope boundary field to every single ticket template. This requires 3 bullet points enumerating in-scope services, explicitly out-of-scope services, and adjacent component owners. This must be completed by the tech lead at the time of ticket creation. Do not leave the boundaries up for interpretation.
Action 2. Establish an off-hours decision authority document. This should be a single wiki page mapping specific decision types to required authorization levels. Is the decision autonomous? Can it be handled asynchronously? Or is synchronous discussion required? Having this explicitly documented eliminates off-hours ambiguity when a junior engineer hits a roadblock and doesn't know if they can proceed.
Action 3. Run a strict 5-minute AI content verification step at ticket acceptance. For any AI-generated ticket, the tech lead must open the source document link, verify the version actually matches the current system state, and manually mark it source verified before committing it to the sprint.
Look at your own sprints right now. Think about the workflows you rely on every day. Which of these 12 questions has your team never asked? We want you to leave your answer in the comments, and don't forget to subscribe to the deep dive.
And I'll leave you with this final thought. The silence you are hearing on your offshore engineering team isn't a lack of initiative. The perfectly rational response to the organizational structure you've built.